wrapping up chapter 2. There's a lot of stuff in chapter 2. It's really important. These last two problem sets, 36 and 37, are a really good summary, though, of everything we've talked about. So focus on that. And some of the problems can be kind of tricky. I know students have trouble once in a while with some problems. My advice is to not to get bogged down. Go ahead, finish the homework, and bring the problem up in class. I'm sure your teacher would love to go over it with you in class. Some of the things you can do, go to the Learning Support Center. Getting together with other students is a really good idea. But when you're by yourself, it's a really good idea to read the problem back. Read, like for example on these first two, be able to describe in words the process of how you would accomplish simplifying this. First of all, what does simplify mean? Simplify means you're trying to, in this case, I would say combine these things. It's a subtraction problem, which is really just an addition problem, right? Addition of a negative. Or opposite. So then you have to get the LCD. You have to remember that. The LCD here is 6x, so you multiply this on top and bottom by 3. And here you multiply top and bottom by 2. So what do you end up with? You get 9 over 6x plus negative 10 over 6x. I get negative 1 over 6x. I think that's right. Okay. This one is a division problem. When you divide, remember you don't need the LCD, you can just flip over the second one and multiply. And when you do that, it looks like the x's cancel, right? So your answer is 9/10. Okay, so let's do a few more, then I'll give you some to try it. Okay, this is a division problem. So you'd flip over the second one, multiply by the reciprocal, and then it becomes a multiplication problem. What do you do next? When you multiply, you want to reduce it, so you start to factor. This becomes 5 times a times 3 times 2 on the top, and you'd use the distributive law, right? Whenever you have more than one term, look for the distributive law. You get 3 times a plus 2. Any common factors here? Yeah, I think you can take out a 3, forms a 1, and a 2. I get 5a over a plus 2. That's right. The 3 and the 2's cancel, right? Yeah. Let's do another one. Now this is a subtraction problem. Now notice the difference between these two problems. Which would you rather do, the division or the subtraction? I'd much rather do the division in general, wouldn't you? See that minus sign? That's kind of sneaky because when you change the plus and negative, you better make sure that the negative sign governs the whole numerator of the second fraction, right? Now you got to have an LCD. What is the LCD here, by the way? Isn't it 6? So you got to multiply top and bottom of this first one by 3. So what is that going to give you when you do that? Let's see, I think you get a 15a, right? This becomes 15a. Anyway, now that the denominators are the same, you can add the numerators. This is a 15a plus negative 3a. Doesn't that give you 12a plus negative 6 over 6? Are we done? You think we're done with this problem? Is there any way to reduce this? Reduce, what do you do first when you reduce? You have to factor the top and bottom. You can use the distributive law on the top. You can factor a 6 out, right? And the bottom is just 6. If you wanted to, you could factor into primes, couldn't you? But either way, the 6's cancel, and your final answer should be 2a minus 1, or 2a plus negative 1. That's a good one. That's kind of sneaky. This one, how would you describe this to somebody if you were going to tell them how to simplify this? What would you do first? It's a division problem, but you would first work inside the parentheses. Don't you need the LCD here? What is the LCD here? It's 12, isn't it? What's the LCD here? It's 2. So let's do that. Let's get the LCD here. We're going to multiply this first one on top and bottom by 4, top and bottom by 3. Now over here, think of it as negative x over 1, so we got to multiply top and bottom by 2, right? So 2 there and here. So look at what we get. You get 4x over 12 plus negative 3x over 12. Isn't that just 1x over 12, right? Here you get x over 2 plus negative 2x over 2. Isn't that just negative x over 2? So now it becomes a lot simpler, doesn't it? Flip over the second one and factor, and it looks like the x's cancel. There's also a 2 that cancels. So what you have left on the top is a negative 1, and you have 2 times 3, so the answer is negative 1/6. That's right. Let's do one more, and then you try some. This one, let's see. This one, we do the multiplication before the subtraction, right? This is 3/2 times the quantity y minus 2 over 6 minus 3/4. So let's go ahead and do that. Let's multiply straight across. So the 3 multiplies the quantity y minus 2, right? And 2 multiplies the 6. Let's also change to additive form here. Change to plus a negative 3/4. Now, can we reduce this first one? It's a good idea to reduce when you're about to add. You know why it's a good idea to try to reduce the fraction before you add? It makes the denominator a lot smaller, doesn't it? Huh, I didn't do that, but it would have been a good idea. Anyway, I would have probably said we should have reduced this, but anyway, I didn't do that. I should have. Anyway, so here we go. Let's go ahead and finish this problem anyway. We can still do it. I just think it would have been better if I had reduced that initially. But so what do we do now? Well, we're going to try to get the LCD. So let's multiply this top and bottom by 3, right? So you get this fraction plus negative 9/12. When you add, you get 3y plus negative 15 over 12. You see, if I had reduced this before I get the LCD, I think my LCD would have been smaller and I would have saved all this work at the end. But we can still get the right answer. You factor the 3 out of the top, and you factor the bottom, you can cancel the 3. That's why your final answer is y minus 5 over 4. And if I had been smart, if I had reduced it there, I think it would have saved me some work. Anyway, we can still get there, right? All right, here we go. All right, here we go. Why don't you hit the pause button and try these two. On the first one, notice the difference between this one and this one. This one you just want to reduce it, so you have to factor this one. This one you're going to have to get the LCD. So let's do this one first. When you factor the top, you're going to take a 3x out. Use the distributive law, remember? Distributive law, because there's two terms. Here you use primes, so you can cancel a 3 and an x. They form a 1. You have 1 minus 2y on the top and 4y on the bottom left. Here, what is the LCD? Can you tell me what the LCD is from these two fractions? It looks like it's going to be 10xy. Is that what you got? So what does that mean? That means you're going to have to take this first one and multiply top and bottom by 2, and the second one multiply top and bottom by y, right? So that's why we get 6 over 10xy plus negative 6y over 10xy. So when you add them, be careful, these are not like terms, you got to leave it like that. So are we done? Can we reduce this at all? I say yes. You can factor a 6 out of the top using the distributive law. You factor the bottom into primes. Now let's take the 6 and write it as 2 times 3. Let's go into primes here on the top on the 6. Any common factors there? Looks like a 2. So when you cancel the 2, or when you remove that factor of 1, you have 3 times the quantity 1 minus y on the top, and you have 5xy. You could leave it like that, or if you wanted to, you could multiply the top out. Either one would be correct, okay? As long as you've reduced it. Okay, let's do 2 more. All right, go ahead, hit the pause button again, and try these 2 on your own. We'll go over them in just a minute. On the first one, I'm going to get the LCD. You know what the LCD is here? Because you're adding. It's going to be, what is it? I get 12 alpha beta. Or you can write AB. If you don't like alphas and betas, you can just change it to A's and B's. That's what we have to make them into. So what do you have to multiply the first one on top and bottom by? I'm going to say 6 beta. What do you have to multiply the second one on top and bottom to get this? I'm going to say 2 alpha. Ooh, 2 and alpha next to each other? Ooh. The last one, I'm going to have to multiply top and bottom by 3, right? So what you end up with is 30 beta over 12 alpha beta. This becomes plus 6 alpha over 12 alpha beta. This becomes plus negative 3 over 12 alpha beta. Now look, you see any like terms? When you have the common denominator, you can add the numerators, but are those like terms? The answer is no, so you just got to leave it like that. Okay, let's do this last one. This last one doesn't look quite so bad. Did you do the division first? Whoops. Did you do the division first? So then we're going to flip over the second one. Flip over the 9x over 4 and call it 4 over 9x. Now let's go ahead and multiply this, but like I said, it's a good idea to reduce this before you get the LCD. It's going to make your LCD smaller. When you factor, it looks like you can take away a 3, forms a 1, and the 2's. So all that's left on top is a 1. I think you have a 2 times a 3 times x on the bottom. Isn't that a lot nicer to get the LCD there than what this was going to be? LCD is 6x, multiply top and bottom by 3, so you get 15 over 6x plus 1 over 6x. I get 16 over 6x. So it sure is nice to be done finally, isn't it? Oh, we're not done. You can reduce. Don't forget to factor at the end. When you take away when you factor, you can take away a factor of 2. Final answer 8 over 3x. We're done. See you next time. Bye-bye.